Hello. In the current scenario of COVID epidemic, let us discuss about something about the epidemic and how to describe the epidemic. Topic to be discussed are types of epidemiological studies, the difference between different types of epidemiological studies, descriptive epidemiological studies and its types, the time, place and person distribution of disease and how to describe the disease, and use of descriptive epidemiological study and its limitations. Any epidemiological study can be classified according to the study design. If we assign any exposure, it will be an experimental study. And if it is not any assignment of any exposure, then it is a purely observational study. If an observational study has a comparison group, it is an analytical study. If it doesn't have any comparison group, then it is descriptive study. In case of the experimental study, where the random allocation is there, according to that, it is divided into two types. Either random allocation is done, then it is randomized control trial, and if no random allocation is done, then it is non-randomized control trial. In the observational study group, the analytical study is also of two types. Either it is a longitudinal or cross-sectional study. If it is a longitudinal, it goes along the time frame, and if it is a cross-sectional, it is going across the time frame. If it is going along the time frame, either it starts from exposure to outcome or from outcome to exposure, depending upon the study design. So if it is exposure and we are following that event and ultimately got the outcome, then it is a cohort type of study. But if we are going back along the time frame and starting from the outcome and went back to find out what exposure this group of people are exposed to, then it is a case control study. Now, this kind of epidemiological study, the study of occurrence and distribution of disease, mainly dealt with the descriptive kind of epidemiological study. And if this further studies to determine the validity of a hypothesis concerning the occurrence of disease, then it is analytical study. If it is a deliberate manipulation of the cause is predictably followed by alteration in the effect and which is not due to any chance, then it is an experimental study. This overview of this epidemiological design strategies. The descriptive can be according to the population or it can be according to the individual descriptives. It is a population among the population, then it is a correlational studies, and if it's among the individuals, then it is either in form of case report, case series, cross-sectional studies. Analytical studies is mainly observational and it is of two types, case control and cohort. That cohort can be also retrospective and prospective. Interventional or experimental studies can be a randomized control trial where there is random allocation of the study subject is done, or if it is not done, it is field trial or clinical trial. So what is the difference between the descriptive type of study and analytical type of study? In the descriptive study, epidemiology deals with the question who, what, when and where. While the analytical epidemiological study, it deals with the remaining question why and how. So among those five or six questions, the first four is answered by descriptive study, and the next two, that is why and how, is answered by analytical type of study. Now, what is the difference? The descriptive study is done where we know very little about a disease, some new emergence of disease where we want to study what are the factors who are affected, the different types of pattern of the epidemiology. But if you have some knowledge, when you have some knowledge and you have some hypothesis and that can be tested, the hypothesis means the assumption that can be tested, it is in the analytical study when there is some insight about the various aspects of diseases available. The descriptive study, it relies on the pre-existing data. An analytical study develops a new set of data. Descriptive answers who, when, where. An analytic answer why. It illustrates the potential allocations, while analytic evaluates the causality of association. The descriptive studies are relatively inexpensive and less time consuming than analytical studies. The pattern of disease occurrence in terms of who gets sick and who doesn't, what rates are biggest, the rates are highest or lowest, or some temporal pattern. Like in the current scenario of COVID epidemic, we want to describe what kind of people are more affected, whether any risk factor is there, who are those age group who are at high risk of infections, who are landed with the complications, what are the areas where we find more number of cases, where there is any cluster of disease, or is there any seasonal change if we follow for a long time. So these are the possible information can be achieved by the descriptive studies. The data provided are useful for public health administration, for allocation of resources, and epidemiologists to fast-test the risk factor determination. The descriptive epidemiology, as we have mentioned, it is of various types. It is a correlational studies or case reports where we just say some unusual presentation of a particular case. We only report that particular case, or it may be a cluster of cases where we report case series, or a cross-sectional study where we find out the the person distribution, the place distribution, and the time distribution of the disease. The correlational studies or ecological studies measure the represent the characteristics of entire population. It describes the outcome in relation to age, time, utilization of service or exposures. But what are the advantages? We can generate hypotheses for case control studies or cohort studies and for environmental studies. We can target the high-risk population, the time periods, and geographical distribution of a particular disease. But there are certain limitations. So, because of the data are for groups, we cannot link the disease and exposure in particular individual. We cannot control for the potential confounders. And data represent the average exposure rather than individual exposure. We cannot determine the dose-response relationship. And caution must be taken while avoid drawing the inappropriate conclusion or ecological analysis. Correlation of disease of occurrence. The ecological studies used as a first step in determining association. So if we plot this along on a graph, and along the x-axis we plot prevalence of this factor, and this is burden on the y-axis, then we can get a nice plot of the relationship between the burden of disease and along with the risk factor. For example, we can plot the smoking and lung cancer. And if we find the correlation coefficient of +1, then absolutely correlation. If it's a -1, then it is no relation. So it quantifies the linear relationship between exposure and disease. The case reports and case series. Report of a single individual or a group of individuals in the same diagnosis. What is the advantage? We can aggregate cases from different sources to generate a hypothesis and describe a new syndromes, like in hepatitis and AIDS. But what are the limitations? We cannot test for statistical association, so there is no relevant comparison group, so we cannot generalize the findings. And it based on the individual exposure, so it might be a quantitative. The case report or case series, important interface between the clinical medicine and epidemiology. The most common type of studies published in the medical journals are mostly the case report or case series. So these are some examples, this like the Frisbee finger, like the AIDS in between the 1980 to 1981, where some people are presented with the pneumocystic kidney infection, and this pneumonia was diagnosed among previously healthy young homosexual males in the Los Angeles. The cross-sectional study or the prevalence study, where we measure the disease and exposure simultaneously in a well-defined population. What are the advantages? It cut across the general population, so not simply those seeking medical care, and is good for identifying the prevalence of common outcomes such as the arthritis, blood pressure, allergies, or any other common ailments. But what are the limitations? It cannot determine the exposure-restricted disease, or it considers the prevalent rather than incident disease. So result will be influenced by the survival factors. Cross-sectional studies can be used as a type of analytical study for testing hypotheses when the current values of exposure variables are unanswerable over time, and it represents the value present at the initiation of disease, that is the eye color or blood group. So risk factor is subjected to alteration by disease, but only for the hypothesis formulation. So now come to the descriptive epidemiology in detail. So mainly the purpose of doing descriptive epidemiological study is to describe a disease in terms of time, place and person distribution. So if we want to answer who are affected, it is the person distribution, where the more common the clustering of disease, so it is the place distribution of disease, and when it is occurring most, so it is the time distribution of disease. So these three actually describe a epidemic. So in case of person who is getting the disease, there's many variable factors like age, sex, race, occupations, their educational status, their particular risk factors that makes them more prone to certain kind of disease. So in that case, we have to make a case definition first. Set of standard diagnostic criteria must be prepared in order to identify a person as a case in a particular disease. So case definition should be prepared beforehand. It ensures that all persons who are counted as cases actually have the same disease. Typically includes the clinical criteria, which either may be according to the signs and symptoms, it's only the clinical suspicions, or it might be a lab according to lab results. So that means the lab tested or lab proved cases. So it depends upon the type of studies and designs, and according to what we are going to set the clinical criteria. Sometimes the restrictions on the person, place and time. The characteristics of persons: age, sex, ethnic group, socioeconomic status, nativity, the religion, marital status, occupation, etc. So these are some empirical examples like some disease Y or X. So in that cases, the reported cases and according to y-axis, and the age group according to x-axis, and it shows that it is more in the older age group who are more than 60 years old. So age may be a very good criteria for guessing, for suspicion of a probable diagnosis. Like if you have a preschool children where it comes with the fever and rash, the first thing we keep in our mind that it might be a measles. If having a sore throat or a patch in a throat, it might be a case of diphtheria. If it is a middle-aged person with a lump, with a low-grade fever, malaise, weight loss, suspect cancer. If it is an elderly person, if it is coming with a kind of chest pain or some neurological symptoms, we found that it might be related to atherosclerosis and it might be a case of coronary artery disease or ischemic heart disease, or it might be leading to some kind of cerebrovascular disease. The two age group, we have a bimodality of phenomenon. Like some of the disease which shows the bimodality phenomenon is more prevalent in the two age group, like leukemia and Hodgkin's disease. It might be seen in the younger age group or it might be in the later age group. The this graphical representation shows that distribution of this disease according to the sex of the person affected. So two columns, one is denoted by this males and other is actually for females. The two different types of designs. It shows that almost all the age group, it is the males that more affected rather than females. But this difference is much less in case who are more than 65 years. So it gives the idea about the distribution of disease that is more in male in case of the younger age group, but it is almost nearly equal in case of the older age group. We found this kind of distribution in kind of coronary artery disease, something like that. So in the sex, the lung cancer, the coronary heart disease is more in men. Rather, diabetes, obesity, myxedema more in women. And the factor responsible is genetic, cultural and behavior. It is also found that marital status also plays an important role in the epidemiology of particular disease. In case of the unmarried people, it is found breast cancer is more common. Rather, in married women, the CS cervix, that is cancer cervix, is more common. So it is in general found that mortality is more in case of unmarried people. Certain occupation is related to certain kind of disease. Like those who are agricultural workers, they are more prone to tetanus and ankylostomiosis. But in case of the industrial worker, it is found that the pneumoconiosis is more prevalent, which is not found in case of the agricultural worker. Similarly, the drivers are more prone to accidents. Social class, certain disease, we found that like the hypertension, diabetes, coronary artery disease, more prevalent among the higher socioeconomic status. But it is not the rule. We sometimes found that it is also common in the lower socioeconomic status, but it is more in the higher socioeconomic status. It does not mean that you will not find any case of the hypertension, diabetes in lower socioeconomic status. Similarly, the malnutrition and rheumatic heart disease, it is more in case of lower socioeconomic status. Malnutrition can be undernutrition or it can be overnutrition also. Both are found more in lower. In our country, it is the malnutrition, undernutrition is more in the lower socioeconomic status, but overnutrition is more in the higher socioeconomic status. The factors responsible, the illiteracy, this ignorance, poor standard of living, overcrowding, these actually the factors responsible for occurrence of disease in a particular social class. Behavior and stress also plays an important role in case of the non-communicable disease. Human lifestyle or behavior like the addiction of smoking, alcoholism. This drug abuse also play an important role. The smoking prone to a lung cancer, the coronary artery disease. This alcoholism, this makes a person prone to liver disease. This drug abuse, or especially the intravenous drug abuser, they are prone to some kind of communicable disease like hepatitis B, C and HIV/AIDS. The overeating leads to malnutrition, overnutrition and multiple sexual partner prone to the sexually transmitted disease. The stress also increases the susceptibility of disease and it exacerbates symptoms. Migration of people from one place to another, it helps in the movement of the disease transmission from one place to another. and it helps in the spread of the disease. This movement of the people from rural to urban areas resulted in the spread of the disease, not only from the rural to urban but also from the urban to rural. The challenge of the prevention and control of disease is one of the most important challenges by migration. Now come to the time distribution of disease. When it occurs, it is a temporal distribution. It ranges from hours to decades. The type of disease dictates the time element to be used, and usually we use the frequency of disease. If we plot graphically, we use the frequency of disease along the y-axis and x-axis. Along the x-axis, it is the time. See, this graph is showing. Along the x-axis, we plotted the time in terms of month in days, and along the y-axis, it is the number of cases. And we found that the most clustering of cases in the last week of August and the first week of September. So it is usually the highest number of the cases in the 1st of September. So it gives the idea about the clustering of the disease according to the time. It might be a secular change. It is the long term. It might be a point epidemics, short term change. Cyclical, it comes in the different cycles, and seasonal variation. Every year, in a particular season, the disease outbreak comes. This is a secular change of disease. It is a change of disease pattern over the years. It's a long term. This is also different types of examples of secular change. What are the possible reasons for changes in the trends? Either it is a natural causes, such changes in age distribution of the population, changes in the survivorship, changes in the incidence of disease resulting from various genetic or environmental factors. Or it might be because of the artificial causes, like errors in the numerator due to the changes in the recognition of disease. Previously, the case definition may be only according to the clinical symptoms. Now the very sophisticated tests have been invented, so now the more number of cases can be detected. So the disease burden, the numerator, is increasing. It may be the changes in the rules and procedure for classification of the cause of death. It may be the changes in the classification of code of causes of death, changes in the accuracy of reporting age at death, and errors in the denominator due to the error in the enumeration of the population. If we don't have a proper enumerated population as a denominator, then we might have a different. The other phrases, the cyclical trend, it recurrent alteration in the occurrence interval of frequency of disease. The secular cyclicity, it varies according to the level of immunization and build-up of susceptibles. Like hepatitis A every 7-year cycles, measles 2-year cycle, as it was observed previously. Short-term cyclicity is chickenpox, salmonella, on daily basis. Seasonal cyclical variation of the disease, a particular time of a year or season, like the seasonal fluctuation in occupational activities, environmental factors, and recreational life. So we found that these are graphical representation of the seasonal trend of pneumonia and influenza death from year 1934 to 80. See, the peaks are quite high in the earlier years and it comes down over the years and gradually comes down. Endemic, epidemic, and pandemic. So what is the difference between these three? Endemic is the habitual presence or usual occurrence of a disease within a given geographic area, in a particular geographic area. But while occurrence of infectious disease clearly in excess of normal expectancy and generated from a common or propagated source, then it is an epidemic. It is a more than normal expectation. But what about the pandemic? What we are experiencing nowadays? That is one good example is the coronavirus infection. It is a worldwide epidemic affecting an exceptionally high proportion of global population. So we are observing this currently the coronavirus pandemic, and it affects almost 208 countries of the world, and the global population, a huge number of population has been affected and a huge mortality. Now come to the point epidemics. This is very short-term changes like the example is AGE or food poisoning. So acute gastroenteritis or food poisoning, the short-term changes occur over limited time frame. It might be within hours, might be within days, weeks, or even months, but it's a very short-term exposure or disease with a short incubation period and illness duration. So this is the example of this point epidemic. This gives an idea about the quick rise and quick fall, and this curve is showing that the very clustering of disease within the 1 month and maximum within 1 week. So this is another example of point epidemics. See, within the highest peak is within 2 to 3 days, and after that it comes down. Now what about the cyclical trends? That it may be either long term or short term even, but these are coming in cycles. Due to the other factors, some are seasonal, but some are maybe the other factors like the immigration, school year, military deployment. This is the example of cyclical trends of disease. See the peaks of the disease load at regular intervals. Seasonal variation can be seen for some disease or condition falling within the calendar year. See the some of the cases of this meningococcal infection coming down, and while it comes down, the cases of encephalitis is going up. Another example of seasonal variation. Time clustering of data can sometimes be used to trace the beginning of introduction of a specific causal effect. Like the example is toxic shock syndrome and thalidomide and birth defect. Thalidomide and birth defect is which one is marketed in the Europe 1950s as a sleeping pill, treated for morning sickness in the pregnant woman, and it was found that the baby is born with a multiple vein defect. And that's now we found that causality, and there is a temporal association of this thalidomide and birth defect, and then come to the conclusion. The toxic shock syndrome is also an example of the Staphylococcus aureus infection in women using newly introduced hyper-absorbent tampons, and it was found that if the tampons were used for more than 24 hours, the people are more exposed to this kind of infection, and it is found there is association between this toxic shock syndrome along with the tampon user. This is an example of time clustering of the disease. It shows that in a particular time when the tampon introduced, and there was a rise of cases of TSS, and it was the peak in 1980s, and after that tampon was taken off the market while we found there is a temporal association, and after that it gradually comes down. Now the place distribution of disease, where there are rates are higher or lower, geographic location of the source and geographic location of the reservoir. The broadsheet pump that gives the idea about the clustering of the cases, and see this, there is a clustering of cases in the area where the water supplied by the broadsheet pump, and it was Sir John Snow who first noticed the occurrence of this clustering of the cases, and he comes to the postulation that this is the pump that is supplying the infected water, and who are affected are consuming actually the water supplied by this broadsheet pump. So there we found that there is less distribution of the disease and clustering of cases, and come to the conclusion that this is the causative agent and this is the outcome. 5 criteria of place distribution. The increased rate observed in all ethnic groups in that area. Increased rate not observed in the person of similar group inhabiting in the other areas. Healthy person entering that area will get ill at some point of time, same frequency, and people who leave do not show similar levels. Similar level of infestation in other species is also found if it is a zoonotic disease. So characteristics relating to the place, international, it could be an international place distribution like in the COVID epidemic. Variation within the countries, we can see the urban-rural variation. Some of the non-communicable disease more prone in the urban people rather than the rural people, where we found that the helminthic disease are more in the rural population. Some local areas were particular area, like some of the areas, who are having a particular industry who are emitting some sort of toxic agents, and that area, people inhabiting that area are more prone to development of disease condition related to that toxic substance. So this gives a local clustering of these cases. The building maps helps in the like example of food poisoning, where we can use the building maps like who are the or it might be cases of other disease outbreak, where we found that who are the inhabitants in a particular area of the building who are affected by a particular infection. Or it might be a food poisoning where some in a hostel, a particular, it might be having one or two mess, and it have a certain group of people who are taking the food from a particular counter, they are more affected rather than other groups. So in case of the building maps, we can also track down the temporal association, this causality, or according to the cluster of the cases. See, this is the distribution of according to this national level within the country, and we found that there is a different district gives a different um, occurrence of the disease load according to different states, and is this variation within a country. It may be a local variation in a particular area. Some are the areas more affected by a particular conditions, but some areas are not at all affected. These are the example of building maps, where some are the apartment or some of the rooms or this are more affected by a particular aerosol, but who are not affected. So this is showing that the clustering of a case in a particular apartment blocks. Interaction of the time and place clustering, and this might be because of migration. So what are the limitations of descriptive study? Thus no account was taken of variability between the individual in the study. So there is no account of variability among the study group. So we have only the data for the groups and no exposure and outcome data for each individual of the population. So it is only the group data we are finding. So according to this data, we can postulate a hypothesis, and that hypothesis can be tested further by the analytical study. So any kind of epidemiological study, if you want to study an epidemic, firstly we have to conduct a descriptive study, and on the basis of that descriptive study, we find that there are some postulations. So we can develop this postulation, that is the hypothesis building, and this hypothesis building is done only by descriptive study, and on the basis of that building up of build-up hypothesis, we can test it further by analytical study. So before doing any kind of analytical study, we must have a hypothesis built up by a descriptive study. So that is the utility of doing a descriptive study. Now to sum up, the epidemiological studies are of three types, mainly descriptive, analytical, interventional, or experimental. The purpose of descriptive study is to develop hypothesis. An analytical study is for testing of hypothesis. and experimental for testing of hypothesis by manipulating one or more independent variables. The type of is descriptive epidemiological study, correlational study, case reports, case series, cross-sectional study. Descriptive epidemiological study answers who, where, and when by time, place, and person distribution of disease. Time distribution of disease presented by various types of epidemic curve or epicurve. This is very important in the current situation of COVID pandemic and investigation to find out its strains. The place distribution of disease presented by spot maps which help to identify the outbreak of disease and its probable source and mode of transmission. Thank you.